So we're recording on the internet.
Okay.
So we're just going to go over some of the organic stuff. Test looks a lot like what the review looks like.
Okay.
See anything that looks strange on the test or unfamiliar?
On the review?
Yes.
Or let me just check right now. I haven't really seen too much of it.
All right. Well, so it's organic chemistry.
Yeah.
Okay. Good. And this is question 1. I've just drawn all the molecules up here, but I've given that condensed, sorry, not the condensed structure, but the skeletons without the hydrogens. And you just have to go through and name them based on the functional group. So here's the first one that's on the review.
Yeah.
And can you name it?
MEPB. So it's pent. Is it like there's methane?
So yeah, this one, it's 5 carbons. So you're right. It's an alkane. There's no particular functional group there, so that's pentane.
Okay.
So
Yeah, I just kind of forget like the names of them. Like there's mesa, ester, propa, but. Like yeah, I just forgot the 5th one though.
Yeah, well, I always have to go through them too, right? Methyl ethyl propyl butyl. What is it? Monkeys eat peeled bananas is one of the ways to remember the first 4.
Okay.
And then after that, it's just it follows the, naming polygons like the Greek.
Yeah.
Pentahexa.
Really weird.
Hept, all that kind of stuff. Okay, so that was an alkane. We go down to this one.
Okay. So it's a hydroxyl group.
Yes, right there. That's the big one. That's the key functional group.
So is it pentoxyl?
So this hydroxyl group on anywhere along there makes us into an alcohol. Okay.
Yep.
So it's going to end in -ol. So, oh my goodness, I don't have a nice place to write this, so I'm going to put it right there.
Or is it pentanol?
And so yes, so it's penten. And because the alcohol could technically be anywhere in that chain, this one gets called pentan-1-ol.
Okay. Or could it be 1-pentanol? Is it?
Yes, you know what? I'll accept 1-pentanol. This is a little bit, I don't know what stage IUPAC is. I think this is a little bit more systematic where they have the 1 in front of what the functional group is. But certainly, if you looked around, you would find 1-pentanol as one of the options for that. Okay, so yeah, I'll take 1-pentanol. The big deal, recognize it's an alcohol. And then, if you're getting the number somewhere in there that's appropriate, that's good.
Okay.
Okay. So here's the functional group on this one. Do you know what functional group that is?
Double oxygen bond. I can't remember that one.
Yeah,
that one's really hard.
Were you able to take a stab at it? So the functional group is the aldehydes.
Okay.
Okay.
Yeah.
And then when you're naming it, you put an AL at the end. So basically, what's the backbone here?
Bute, like butane.
Yeah, that's right. So this is butanal.
Butanal. Okay.
And
yeah. Sorry.
Oh, I was going to say, aldehyde is always at the end of the chain. And so you don't have to number these ones.
Okay.
Okay?
So the hydroxyls you have to number. Which other ones do you have to number?
Yes. So this alcohol, it's an alcohol if it's got a hydroxyl group anywhere in the chain.
Okay.
If it's got a double bonded oxygen and it's on the end, then it's an aldehyde. And then if it's anywhere along the chain but not on the end, it's a double bonded oxygen. It's a ketone.
Or a ketone or an aldehyde?
It's an aldehyde if it's on the end. It's a ketone if it's on the chain somewhere.
Oh, okay.
Yeah, that's right.
Yeah. Okay. So to number 4 now?
Sorry, what was that?
Should we go to number 4 now? The fourth. Could you hear me?
Oh, yeah, I can hear you, but just barely. I don't really know whether it's your microphone or my.
I think it was just the internet kind of bugged out.
All right. There, say something now when you've just leaned in a little closer there.
Yeah, hello? Are we good now?
It's almost the same.
Okay.
Okay. The connection was good last time. I could hear you
Yeah,
really well.
I'm at home this time.
Yeah, okay. Maybe you just talk more quietly when you're at home.
Yeah, maybe.
Okay. Are we good to move on?
Yep.
Okay. So here's an oxygen right in the middle of this one. So what functional group does this belong to? This one.
So if there's an oxygen in the middle, is it a ketone then?
Well, a ketone would look like this.
Oh, so it's a double bonded oxygen.
Yes, it's a double bonded oxygen, and so you'll notice this is an oxygen, and it's in the chain. So it actually makes up part of the whole chain.
Okay. Can't really think of which one had that.
Yeah, so we've got esters and ethers. And so this one, with the oxygen here and nothing else, is an ether.
So that's an ether. So that's a 4-carbon backbone?
Yeah, now we have, so ethers and,
Oh, this is the one with the oxygen in the middle, right?
yeah.
Oh, okay then.
So we actually look at the two backbones. And so if it's a 2-carbon backbone, it'd be an ethane.
Yeah. So.
Okay.
Yep.
So if we were just going crazy, we'd call it ethyl ether.
Okay. Or could you call it diethyl ether?
That's exactly right.
Yeah.
You would actually call it diethyl ether.
Okay. So for these ones, we should check the 2 different carbon backbones that are getting split by the oxygen.
That's right. Okay, so you look either side of the oxygen, and you wind up with 2 different carbon backbones, and those make up the name.
Okay.
Yeah. Okay, so this is diethyl ether. You might get something like ethyl methyl ether, you know, if this was 2 and that was a single carbon.
Okay, but if they're
In
both
that case,
yeah.
you're just going to organize the names in sort of in alphabetical order.
Okay. But if it's 2 of the same, then you could put a di prefix, right?
That's
Okay.
exactly right. Yeah.
Okay.
Okay. Here we go. We've got NH2. So that's a fairly important functional group, especially for biology.
Okay. 1, 2, 3, 4, 5.
Can you name the functional group?
So it's a 5-carbon backbone.
It's a 5-carbon backbone. Yes, that's
Yeah.
right. So it's going to be a penta something.
So penta. Used in biology. Is this one of the last ones that we did?
Yeah, I think so. Yeah.
Yeah.
So this is an amine. So the so the NH2 here makes it an amine. So this is pentanamine. Okay. So the pentas part is right. NH2 makes it an amine. So it's pentanamine.
Oh, okay. Yeah, it's kind of harder without the hydrogens because I'm normally used to seeing all the hydrogens and the carbons.
Oh, is that right?
Yeah, I'm
Yeah.
not really used to like not seeing those.
So yeah, there are actually about 4 different ways that you can see the organic molecules sort of expressed. I actually sort of left off the hydrogens because I didn't want it to crowd out the board
Oh,
and be busy.
yeah, that's true. And plus, it looks like that inside the test review too.
Yeah, so yeah, you're never sure, what you might be seeing.
Yeah. Okay.
Okay, so here we go. We've got a double bond here. What's the backbone?
Well, would the last one count? So it'd be Mary eats peanut butter. Is it pentene because it's a alkene?
Yes, so it's an alkene, and in that case, it's pentene. And we should specify where it is.
So pentone.
Pentone, yeah, that's right. So we always number it trying to get the lowest number possible. So we wouldn't call it pentforine, even though that would kind of tell us where that double bond is.
Okay.
We
Why is
start
that?
numbering from the side that's going to give us the lowest number in the name.
Okay.
So this is our carbon number 1 right here.
Okay. So got that. So when it's pentene, would it be 1 dash pentene then if I was to write it without the 1 in the middle?
That's right. You would just go 1 dash pentene.
Okay. So
Also acceptable.
okay. So is it for the hydroxyls and the alkenes that I put the prefixes?
That you put the
The prefix of like 1 on it?
yes, so those are 2 examples. Where you have to specify, where you have to make sure you're specifying what functional group it's going on.
Okay. Are those the only 2 that I'll be needing to put?
Well, now that I'm looking at it, we could call this 1 pentanamine, I guess.
Okay. So is it for the ones that could be like put into different spots, I guess?
Yeah, if it can go anywhere on the chain, then you usually have to specify it.
Okay.
Okay. So this ether, the fact that you're using the functional groups on both sides means that you're not going to have to specify where that oxygen's going.
Okay.
because you're just going to, this tells you what the two chains are that are linked together. So you really don't have to specify a location for there.
Okay. How about the butanol? Could you put it in for that?
Okay, so the butanal right here.
Yeah, butanol, sorry. Yeah.
Yeah. So the fact that this is an aldehyde means that the aldehyde group is always on the end carbon.
Okay.
It's
So,
always on the terminal carbon, or if you want to look at it, the first carbon. So for an aldehyde, you never have to specify the number.
okay. So, aldehydes have like it's always at the very end for
Yes,
the
that's right.
aldehydes? Okay.
Yeah.
Okay. I think I got that pretty well. We're good? Yeah. Oh, could you still not hear me that well?
Say that one more time.
Could you not hear me that well still?
Sorry, one more time, Zane.
Could you not hear me that well?
Yeah, it's still a little quiet, so that's all right. I don't know. Go into your control panel for a minute and see if you can turn up your microphone. Might be
Yeah.
able to.
Trying to do. Microphone. Is this a control room on the side?
Oh, no, I was thinking right on your own computer.
Oh, right, yeah.
Sometimes there's a way you can turn up your microphone a little bit.
Okay.
It could also just be, you know, the way the hardware works.
Yeah. Yo. I can't find. I can't really find a spot where like I
Yeah,
can
okay.
put my mic.
We'll just struggle through then. Don't worry about it.
Okay.
We'll use hand signals and stuff like that. It's not that bad. I can actually hear you most of the time, so.
Okay. I have another headphone with a mic on. Do you want me to get that?
I think we'll be okay.
Okay. Yeah.
We'll try and struggle through. I can mostly hear you, so it's not that bad.
Okay.
Okay. So next one, we're actually we're given the name. And then we are asked to draw the organic molecule. So this is pentan 2-one. How many carbons in the backbone?
5.
5, yes. Yeah. And so I'm going to leave the hydrogens off this one. Pentan 2-one.
Okay.
What's the functional group?
Own is it's
This one is a ketone.
Oh, okay. So we
Yeah.
haven't. Yeah, it's kind of hard to remember all these.
Yeah, so you know what? Just make up flashcards and just cycle through them. I think you've got about, what is it? It's 7 or 8 functional groups or something like that. So
Yeah, I think around.
fairly straightforward. You know, it's just a matter of memorizing them and going over them a few times.
Yeah.
Looking at a few molecules and saying, oh yeah, that one's a ketone. All right. We have to place this functional group, this ketone. Which
So-
carbon do you think we should use?
On the
I'm
second
going to
carbon?
point. This one?
No.
No. This one?
Yeah.
Yeah, we can use this one.
Oh, so is this the one that's like the other type of aldehyde?
Yeah, that's right. Looks just like an aldehyde, but the double bonded oxygen is in the middle of the chain somewhere.
Okay.
Yes. And so we have to specify exactly what carbon it goes on. Whoa, it looks good. Looks just like the other one. Yeah. Yep. Yeah. So Zane, just so you know, it would be just as correct to put it there. In which case, this would be carbon 1 and that would be carbon 2.
Okay.
Exactly the same molecule.
Okay, but it doesn't really matter, does it?
It doesn't matter. That's right.
Okay.
Yep.
All right.
Okay. Next one. Also a very, very important class of molecule. So you actually put this functional group on your French fries. Not this acid, because this one actually has a kind of a bad smell.
Oh.
But butanoic acid. How big is our backbone?
4. So we have 4 carbon backbone.
Yes. Oic acid. So
Um,
making up that functional group. Do you remember what these are called as a class?
Oic is. I remember butanoic, but I forgot what kind of class it is.
So these are the carboxylic acids. And so carboxylic acids have that double bonded O,
And
and
an
then
OH.
this hydroxyl group. Okay? So this is actually an acid because the oxygens are taking these, a lot of the electrons away. This hydrogen breaks off fairly well, not like super easy, but it makes it into an acid basically. So when you put it in water, you're going to generate some hydrogen ions. And so these are the carboxylic acids. Vinegar is ethanoic acid. Some of the backbone, like some of the molecules that make up all the backbones, the proteins in your body, they have a carboxylic acid group and an amino group. They're called the amino acids. So pretty important class of molecule.
Okay.
But there's the functional group right there.
All right.
Okay, and that's carboxylic acid. So once again, just make up a bunch of flashcards.
And just cycle through, right?
Just cycle through them, yeah. Yeah, go both ways, look at the name, try and figure out what the functional group is, look at the functional group, look at the molecule, and then try to come up with the name.
Okay.
Okay, here we go. Propan, 2-ol. And you would write 2-propanol, and you would be fine in writing 2-propanol.
Yeah. Would you just prefer it to be propan-2-ol or just having the number in between?
Yeah, you know what? Right now, I'm going to straight up say I don't care.
Okay.
Yeah, when you go through like some of the programs that do the systematic naming, they're always throwing a 2 in here. If you have a complicated organic molecule, it's much better to specify the number in front of the functional group. Like if you've got an alcohol and an amine and all those sorts of things, then you just can't put the numbers out front anymore.
Okay.
All right, methylethylpropyl, 3.
So we're at 3, and it's a hydroxyl group.
It's an hydroxyl group, yeah. There we go. And it's on carbon 2, 1, 2. It's on the second carbon.
It has to be on that one.
Has to be on that one. If you put it on the ends, then that's a different molecule.
Would that be 1-propanol then?
Yeah, if you put it here or here, then it's propan-1-ol or 1-propanol.
Yeah.
Okay. Got it?
Yep.
So this is another one of those kind, we were talking about where there were like two different parts to what seems like the backbone because it's interrupted with an oxygen. So this is a methyl ethanoate. So we've got 2 different carbon chains all linked together in a single string. So what's the size of one of those carbon chains?
It's a methyl one, and then the ethyl one is 2.
Yeah, that's right. So this is methyl ethanoate. Okay, so there's my 1, and here's my 2 carbon one, and then in the middle is an oxygen. Okay, we have to figure out, this is actually, so this is an ether, and what we need to do is we need to figure out where the second part of the functional group goes. And because it's ethanoate, it actually goes on this ethane part.
Oh, okay, yeah, I get that.
Yeah. Oops,
Because
sorry.
it's not
There
part
we
of.
go. It's a double bonded oxygen there.
Oh, is it because? So if it was like ethane methoate or however, it'll be on the first one.
Yes, you're right, except that in this particular case, that's not that's not a molecule. But
Oh,
you're right.
Okay.
Yeah, it's impossible to construct that, but you're right. Like if it was pentyl ethanoate, we'd have 5 carbons out on this side, and then we'd just have the 2 over here.
Okay. So would that double oxygen always be bonded with the bigger carbon backbone?
Not necessarily.
Okay.
Okay, you can tell which backbone it's on because
Mhm.
that's the name the molecule ends in. Okay, so we could actually convert this into 1, 2, 3, 4, 5. We could convert it into pentyl ethanoate. So my longer backbone is out here to the left, but the O8 actually goes on this ethane part because the double bonded oxygen is right there.
Okay. So whatever the suffix is on is what the double oxygen is connected to?
Exactly. Yeah.
Okay. Okay.
All right. Hexanel.
Mary eats peanut butter. Pent hex. So is that 6? Are we looking
Yep,
at?
that's right. And then that functional group, Al.
Is that a double oxygen bond?
Yes. Yeah.
So it's
Where is it in the molecule?
Shouldn't it be the first carbon?
Sure. Yep.
Yeah.
It's an aldehyde.
So aldehydes are always on the first carbon, right? The terminal carbon, you said?
They're on the terminal carbon. Yeah, that's right.
Okay.
Yep.
Pentyne.
Last one, pentyne. And this one really, let's see. Oh, no. No. This one's okay. I was going to say, this one we should have specified where that triple bond is, but in fact, we don't have to.
Okay.
So could I put it here?
Yeah, sure.
No, I can't.
Why not?
Let's see. Oh, yeah, no, just a minute. I could. Yeah, I could. So we should have called this, we should have put a number on it, right?
Yeah, but then would it be Pent 3 ion?
Yeah, so this would actually be not Pent 3 ion.
Or Pent 2?
That's right. Because we have to number from the direction that's going to put the lowest number into the name.
Oh,
Okay.
right. Okay.
So if we started from this end, we would have written Pent 3 ion. Would have been a big mistake.
Yeah. All right. So it's always the lowest number, right?
That's right. You want to get the lowest overall total number in the name of your organic molecule.
Okay. What just happened? Are we good?
Yeah, so I actually see. I think I have a typo on here. Explain why you wouldn't see a molecule named hexenforol.
Does that really?
You should be able to get one named hexenforol. So I think it's a typo. I think what I meant to say would be, why wouldn't you get a molecule named hexenforol? Bet that's what that should
Oh,
be.
the aldehyde. Okay.
Why wouldn't you have a molecule named hexenforol?
Because the aldehydes are always in the terminal carbon.
That's
Or-
right. Yeah. Hexenforol is fine though. Oops.
How would hexen 4 all look like? So would it be would it be the 6 hydrogen? I mean the 6 carbons and
Oh. Wait a minute, Zane. I just figured out why this is wrong.
why?
So yeah, it'd be 6. 1, 2, 3, 4. Okay. All right.
Because you have to choose a smaller number, right?
Yeah, that's right. What would this
Oh,
be instead?
hexen 2-all
Hexen.
or 3-all.
Yeah.
Yeah.
Yeah, exactly. So this would have to be hexen 3-all. Good. Okay. We did actually take a little turn into the aldehydes there, but that's why. I didn't even realize what a good question it was till I drew the molecule out.
Yeah.
So that's an important, it's actually an important skill when you're writing tests is, you know, quickly make these little diagrams, because it's, your head doesn't always work the way it's supposed to. Well, let's just say your short-term memory doesn't always do everything for you.
Yeah. Sometimes I have to look it out.
Okay. Pentan to oic acid. Why wouldn't there be one of those?
So it's a carboxylic acid.
Yep, that's right. So here's our carboxylic acid. There's our
Okay.
functional group.
And there's Mary. So would there be 5 carbon backbone?
Let's see. Yeah, there would be a 5-carbon backbone. And so to have it on the second carbon, I'd have to go out there like that with another one. How come that would never work?
Is it because they always have to be on the last carbon?
Yeah, so take a look at this carbon, right? Now it's got like 5 bonds.
5.
Carbons can only have 4 bonds as a maximum.
Oh, so is it? Well, if that was if it was to be right, would it have to be on the last carbon?
Exactly. Yep.
Okay.
So you could make a pentanoic acid. Nothing wrong with that.
Just not on the final one because it doesn't have that many electrons to share, right?
Yeah, that's right. You can't, it's always got to be on the terminal carbon because you don't have enough bonding potential to add a carbon onto that.
Okay. All right.
Yeah, so you could even just say, oh yeah, this is, you know, the carboxylic acid always has to be on the terminal carbon. So that'd be another way of saying that.
Cool.
Yeah, that looks good. Is it your birthday today?
Not really. Just a couple friends around.
Oh, okay.
Yeah.
All right. So next question. Sort of an important thing to understand about the organic molecules is how those functional groups influence properties like boiling point, freezing point, solubility. Okay.
Yeah.
So you're supposed to put these in order of their boiling point. So pentan 1-ol. So there's an alcohol for you. Pentan 2-one. There's a ketone. Pentanoic acid. So there's a carboxylic acid. And here's our pentane. All right. So the thing that's kind of common, what is common to all these molecules?
Well, they all have a penta, so they have a 5-carbon backbone to all of them.
So every one of these molecules is a 5-carbon atom chain molecule. That's exactly right. So what's different about all of these molecules?
They have different functional groups.
They have different functional groups, that's right. They do, in fact, have subtly different molecular masses as well, because they have different levels of oxygen. But the big idea here is same number of carbons, roughly the same mass of molecule. We need to figure out which ones have the greatest intermolecular forces between them.
Okay.
Okay? So, which one has the least strongest intermolecular forces out of all these?
Pentane would.
Exactly, pentane. It's all carbons and hydrogens. There's not really very much intermolecular force. This, I think, is actually kind of a liquid at room temperature, but heated up, it disappears right away. So this is probably number 4 in terms of its boiling point. Okay. Which one out of these 3 would come next? In other words, have the third highest boiling point?
Wouldn't pentan 1-ol?
Pentan 1-ol?
Yeah.
Okay.
Because it only has the OH on it.
It's got an OH on it. And pentanoic acid also has an OH on it. Okay, and this has an OH. And pentan-2-one, what's the functional group here?
Is it a ketone?
It's a ketone, yeah. Okay, we can put it wherever we like. All right. So hydrogen bonding is actually one of the greatest dipole-dipole style forces we've got. These two both exhibit, have hydrogen, the hydroxyl group, which will contribute to hydrogen bonding between the molecules. So these two are going to have the highest boiling points. Okay. Oh, geez. I said this was, did I say that was the lowest or the highest?
I think you said that was the lowest.
Yeah, okay.
Yeah.
So let's put that down as a number 1. This one, there's no actual hydrogen bonding in this molecule. There's an oxygen and a carbon. So there's going to be a little bit more charge separation between the oxygen and the carbon, sorry. And so this is actually going to be our second highest boiling point. Comes down to these two that have the hydroxyl groups.
Okay.
We just have to decide which one we think has a higher boiling point. Okay.
Yeah.
And so I think this one is going to have the highest boiling point of all, because the oxygen on this side favors, the electrons favor the oxygen that's on this carbon, and we have the hydroxyl group. And so we're going to get the greatest charge separation out of this pentanoic acid.
Okay.
So I'm going to say that this one is going to be the third highest. And this one is going to be the fourth, sorry.
The highest. So.
Yeah, so yeah, that's right. This is going to be the highest right there. Yeah. This one's probably even just a crystal at room temperature. Okay? So what you're looking for there, intermolecular forces, hydrogen bonding being the greatest of the intermolecular forces. And then, you know, if you can get some charge separation like nitrogen and hydrogen, also what they generate what they call hydrogen bonding as an intermolecular force. In other words, holding those molecules together when they're sitting in a pile.
Okay. So hydrogen have the highest intermolecular force, is it?
So, hydrogen bonding, is an example of a very strong dipole-dipole force.
Okay.
Okay, and you get hydrogen bonding when you have an OH or an NH, so nitrogen and hydrogen, or fluorine and hydrogen.
Yeah.
Okay, those are the three groups that lead to a lot of hydrogen bonding that raises that boiling point.
Right. Aren't these permanent dipole-dipole, is it?
Yes, it's the strongest example of a dipole-dipole force.
Yeah, because I remember doing that in Unit 2.
Yes, yeah. Comes up over and over again. It's a pretty important concept in chemistry because it affects the physical properties of molecules.
Okay.
Also affects the solubility.
Oh, yeah.
Okay, so these ones are going to dissolve in water quite readily because you can get the water molecule. It's going to be attracted, the positive hydrogen to the negative oxygen here, the positive oxygen to the negative hydrogen there. So this one's going to dissolve in water much more readily, like pentane. Pentane does not dissolve in water at all. Okay?
Okay. So are we on the last question now?
So the last question, yes. So this is the, you'll see pictures of these. I don't know. Have you ever been to a refinery or driven by one?
Yeah, I think I have before.
You'll see these big, what they call cracking towers.
Yeah, I remember seeing these before.
Yeah, you certainly see them in, pictures of refineries. Usually they take them at night. You'll see domes and these giant cracking towers. And you're supposed to, oh yeah, look at that. Differing is spelled with one F. Crude oil just comes out of the ground, and it depends on where you get your crude oil. It's just a combination of different chain length hydrocarbons. And all of those hydrocarbons can have a variety of end uses, based on their physical and chemical properties. But basically, your hot crude oil is coming in here. Things are mostly coming in as alkanes. And so the lighter stuff is going to go up to the top, right?
Yeah.
So how do the chain lengths compare top to bottom? So we're taking off like pretty hot stuff down here. And we're taking off not very hot stuff up at the top.
Yeah. So is it the bigger the chain length, the higher the boiling point?
So this is going to be our longer chain length down here. Okay, because that's the second thing that affects intermolecular forces is the chain length. They have long chain lengths. Basically, we get what are known as more London dispersion forces. So the molecules are going to stick together a little bit better. So yeah, our longer chain lengths come down here, and our shorter chain lengths come out here. And this is all based on those intermolecular forces. And so, if you're answering a question like that, make sure you say the word intermolecular forces or write it down.
Okay. Wait, so do the longer chain lengths have a higher intermolecular force?
Longer chain lengths, yes, there will be higher intermolecular forces. So they'll have higher boiling points.
Oh, because it's harder to separate them, right?
Yeah, that's right. Yeah.
Okay.
Harder to pull them apart.
Yeah. Okay.
All right.
Yeah, I'll just study for tonight, just understand all the functional groups, and I think I should be good.
Yeah, I think so. Just make those flashcard functional group things. Make sure you go through, draw a few molecules based on their names.
Yeah,
Yeah,
just review that. Okay. So is it tomorrow at 10:30 for the
tomorrow at
20th?
10:30 sounds good.
Okay.
All right.
All right.
We'll see you then, Zane.
Yeah, thank you.
You're welcome.